Hello, this is David Berthium, co-founder of Paper Crane. Today I'm going to talk about what a Geodatacube is. So a Geodatacube is a fundamentally new way of working with geospatial data, both vector and raster data, such as building footprints, street networks, and satellite or aerial imagery. It is a mathematical structure that stores information from multiple sources of data in a single unified way. So today we're going to talk about what this structure looks like through a very simple example. So let's say we were working with building footprints, street data, and parcels in an area of interest. So let's say our area looked like this, and we had a road that kind of meandered along the western region of our area of interest, and we had two parcels to the east of this road, a parcel up here and a parcel down here, and in each parcel we had buildings. So let's say we had two main buildings and a shed, for example, in our second parcel. So what we actually do is we break up this area of interest into compact, contiguous regions of uniform vector information. And as an example, it might look something like this. Now, every point in our region of interest is part of one and only one of these contiguous regions of uniform information. So once these compact areas of uniform information are formed, we generate an adjacency and proximity graph on these areas. So this lets each region know about its neighbors. For example, this region right here, we provide linkages to all of its adjacent elements, like so. And for each of these adjacent elements, we know what that region contains and in what direction it's in. Furthermore, for each one of these regions, we compute certain properties, such as the area, the perimeter, the compactness of that region, and so on, many other different features that we compute. Now, once we have this, relationships between the original data layers can be calculated by performing linear time aggregates over these compact areas of uniform information. And this is really the key idea behind a Geodatacube. This process allows us to very quickly determine key relationships such as overlaps, proximity, adjacency, counts, direction nearest elements, and so on between all of our input data sets. And more complex relationships can be very quickly determined between 3 or more of our input data layers as well. Now, in the next video, we will discuss how to compute these relationships between the input data layers using these aggregation techniques on a Geodatacube. And we will go over some applications of this process as well.